Okay, we are starting stream again. Okay, awesome. It's working now. Okay, so generate parenthesis. So this looks something very straightforward using backtracking. So basically, we take number of available open and number of available close brackets. Um, so available or pushed. Okay, so number of pushed brackets, let's say. So we start with 0 and 0 and we take the total number of brackets available. Um, so now if total number of open brackets is more than total number of closed brackets, then we can push a open bracket. Um, Else we can push both until all the open brackets are used. And then we can only push closed brackets. So if three cases, if open is uh, if open is greater than closed, you can use closed as well as open. You can only use in that case you have subcase in case total used open are already equal to uh, total available, then you can only close. Only then can you use just close. Um, Otherwise, like you can't use open in that case basically. And another case is if number of open is same as number of closed, then also you can use, then you can do just open. That's it. So no need to write it. It's just, I've already said that's the answer. You can just look at the solution now. BRB. Okay, so this is 4 to the power n by root n. So it's the same thing here. Same thing here. Alright, so that's fine. If open is less than max, then you know because you can always open, and if close is less than open, then only can you close. So we talked about this, we talked about this, talked a sub case. I think it was unnecessary because this will cover that case as well without writing an else. Cool. Swap nodes in pair. I very recently did this, in fact, on IB. It's a linked list. You swap nodes in a pair. It took time because there was a case where the last node, like if the number of nodes was odd, then it wasn't working. So actually, it did work better when I reduced the total number of ifs and else's. Yeah, BRB. Okay, sorry, I'm back. So basically, you're given two integers and you have to divide them. without using multiplication, division, or mod. So it's basically probably a bit manipulation or a math question. So one way is an ON solution where n is the answer, is where you add divisor to itself n times till it becomes greater than your dividend. Uh, you just take care of the sign in that case. Uh, Basically make the sign of the divisor and dividend same, and then you can do that. And then in the end, just replace the sign with if the sign was same or different. The cases that you take care of, if the dividend, if the dividend is int min and the divisor is minus one, is one, the answer is int max, but you won't be able to. It's minus int, so don't do something hacky like changing the signs of the actual answer. Maybe or keep the numerator negative because that can contain a bigger number. Or there's bit manipulation, of course, which is probably the right answer. So uh, so I think right shifting means dividing by 2. It's not something you want to do. You want to divide by some number. I think I did this problem also recently, but I actually have forgotten now because maybe I didn't get a good grasp on it. Hmm, so let's think of bit manipulation and division. Hmm. Think I'm gonna have to see the answer. Key observation is the quotient is just the number of times that we can subtract without making it negative. Then we repeat the process by subtracting. So dividend, a left shift dividend by 1. What is temp at the beginning? It's divisor. Why do you left shift it? What does left shifting? This is the corner case I was talking about. And temp is the divisor. Uh, that's 3. You left shift 3 to get 6. Does left shifting square the number? Oh, sorry, it doubles it, right? Yeah. Yeah, no, so it did double it. So then why are we left shifting it till it is less than the dividend? And then with left shifting M, you're not saying the divisor, so it's gonna run only once. Mm. So what does left shifting temp do? Doubles it. So if this number double is less than dividend, then double it, and that number is less. Oh, so it's expressing in powers of 2 is what you're saying? Mm, no. Now dividend is greater than the divisor. So it's going to be a factor of, it's going to be a factor of, because you can represent any number as a multiple of 2. Because you can represent any number as a multiple of 2, what you do is you subtract your number from your divisor from your dividend a factor of 2 times as long as you can. Then you find another factor of 2 that you can subtract from. Basically, what he did in 15 and 3 case in the example was 15. Uh, so take 3, uh, double it, and then double it. So basically, this is actually 3 times 2 to the power 2. Uh, and whatever's left after that is 3 times 2 to the power 0. It's 3. So this is what I mean by every number can be represented as a factor of 2, which means this will be the number that we're trying to represent as a factor of 2, which will actually be whatever is multiplied to 3 in the end to get this number, or as close to this number as we can. Because when the remainder after this step, if it is say your less than this number, that is when we quit. Okay, so you're using this. This is the key to understanding this problem, and then also the steps that are required to do it. Okay, very downvoted, very mathy, very weird. Probably not a popular question asked anywhere, so maybe we can skip that. Okay, let's see what are. So there's a lot of math which we don't need, which we'll not be doing, I guess. I have never done heap questions, max heap, min heap. Um, I've not done DP as such. I've never done graph questions also, I think. Although I do know that it's very similar to say DFS or BFS with uh, a visited array. That's the simplest way of putting it. Okay, anyway, next permutation. Implement next permutation, which rearranges numbers into the lexicographically next greater permutation of the number. Oh, yeah, I saw this question. So what it basically says is so what you do in this, you start from the right. You check if your current pointer is greater than your previous pointer. How is it given? It's in a vector, right? Yeah. So you check if your current pointer value is greater than your previous pointer value. If yes, then you swap those, and that becomes your new endpoint. So you'll check till here now. So basically, you sort of do this, and you sort your remaining array. Let me show you what I'm trying to say. So if say 2, 1. So the answer to this should be 1, 3, 1, 2, 2, right? One, 3, 1, 2, 2. Yeah. So basically your first point where your values are coming from the end, first point where your values decrease, you swap those, and then the remaining array you just sort. So it's a medium question, but it's very simple to code. So for int I equals to nums dot size minus 1. There's just a corner case in case you finish looping and you don't find anything, so you just reverse the entire array. In that case also you don't really need to worry. I don't think we'll have to write any cases for that. Int end is nums dot size minus 1. Int start is 0. Um, I plus plus. I is greater than equal to 0. I minus minus. If I is greater than 0. If nums I is greater than nums I plus 1 minus 1, then that we break over there, right? So int temp equals num I equals num I plus minus 1, sorry, and num I minus 1 equals temp. If I not equals to 0, only then do we do this. And then what do we do is don't even need to save this, I guess. Then what do we do is reverse nums dot begin plus start till nums dot begin plus end plus end. There might be a numerical issue here. Num was not declared. No problem. Start was not declared. No problem. So your output was 1, 3, huh? 2, 2, 1. What was I? I was this index, right? Oh, sorry. Not reverse. This has to be sort. Vector sort. Vector dot begin plus 4 till vector dot end. Hmm. Oh, sorry. Till end, I guess. Don't really have to store end. So if you basically if you got the logic, then I think it should be pretty obvious. So for one, oh, okay. Guess I didn't get the logic right yet. So if it's increasing, it's not just you don't just stop at that. Sorry, if it's decreasing, you don't just stop at that, but you store. So the minimum value will be the minimum value will be what is at the rightmost index. Hmm. So the smallest number is to the right, but the smallest number that is, we want the smallest number that is greater than, don't swap these two values. When it decreases, we pick the smallest number that is greater than this number to the right. Thank you. To bring smallest number greater than this number. Okay. Let's say iterate again from the end. If nums j is greater than nums I, break. J is greater than I. Then we swap nums I and nums j, and then we sort. If swap is a function, j was not declared. Int j. Hmm. So this is I, right? Output is this. And j start from here. As soon as j was, let's check once what are I and j are. So your j is 0, I is 0, 1, 2. Oh, oh, so you have to swap I minus 1 actually. Um, Stop. Minus 1. We add another if I is not equal to 0. Only then do we do all this. Minus 1. This line as well. Okay. Worked for our logic and it worked for their logic as well. Awesome. So basically the change was that you find the smallest number, the largest number after your target, and then put that there and then sort the remaining array. Let's check if the solution is any different. Brute force, let's just ignore that. Single pass. Oh, I used double pass. I'm not sure. So while hey, wow, nice. I used the same thing. That's bloody awesome. That's Is it single pass though, really? Sort of, not really. Sort of double pass. But cool. Same solution. Pretty good. Search in rotated sorted array. Hmm. I'm hoping I've done this one way or the other. So in ON, you can just find where it's been rotated. Whenever the number is this. And but you don't need but you need to use binary search, so it must be O log n. So you check the start of the array and the end of the array. You have that at least. So binary search, if the number is greater than what you want, um, so let's take an example. So say you're looking for 6. Uh, so you land at the center, it's 7. So is 7 greater than what you want? Yeah. So it's probably to the left if uh, the leftmost node is greater than your value, is less than your value. So basically it has to be between the start of the array, as well as your current middle. So mid becomes high, 7 becomes high, and then you can find normally. But say we had something different, an array which was divided in the middle differently, say something like 7, 1, 2, 3, 4, 5, 6, and you're looking for 7. So you come to the center, or say 6 and then this. So you come to the center, you're looking for 7. So is this number greater than what you want? No, it's smaller. So your answer is to the right if the rightmost value is greater than your answer, because this was smaller, so that should be greater, right? If it's sorted, no. If not, then answer is to the left actually. So this becomes the new high index, and I guess that. That's all. It's pretty straightforward again. Oh, this is different. This actually says find the smallest value, and when you do, depending on what is ROT? Yeah, so basically you're checking the rotation with it. That's also clever. Like the skewer is added to the index. I think that's better than what I was saying. Nice. Although I think mine would have also just been if analysis, so that also would have worked. Let's see if I have a solution for the problem as well. Hmm, 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 hmm. So it is array. Sorry, I tried. It's array rotate. Hmm. This is a copy paste. I did it somewhere before. Not use search in rotated sorted array. First, find first last position of element in sorted array. Oh, this is also a binary search. Very simple binary search problem again. I was also asked this in a recent interview. Um, range. Um, first. Hmm. So basically, what this was, so you binary search, find the first and last position. So I think you can just do binary search twice. Once keeping high as greater than equal to, uh, like if a mid is greater than equal to target, then high is a mid. So we find the leftmost answer that way, and the other time low is greater than equal to. And when low and high coincide, that's our answer. Yeah, I don't really need to look into. If a mid is less than target, then low is mid plus 1. So that's how you'll find the first one. And if a mid is greater than target, how you'll find the rightmost one. So I was updating low in this case and high in this case, which either of which is fine. And no, I think either is fine, really. Valid Sudoku. Hmm. I guess we're gonna take a break again. I'm sort of tired. It's been almost 2.5 hours of stream, including the last stream, which was just one break away. Um, okay, thanks for joining, nobody. All right, we will continue in half an hour. That's around 7:30 IST. Okay, see ya.